You're going to need some kind of writing utensil, yes.
Can I go get it out of my locker?
I'll just give you one.
You got your wallet with you. You got it.
Damn.
Right. Wow, I like what you did. Are those permanent?
Perhaps.
They could be.
You should have asked me.
Get a warm-up sheet. If you need a new one. If you have room on your old one, still use it.
Wait, is this the same one?
Sure.
It's a big dollar.
Wait, do we need new warm-up sheets?
You can use a new one or your old one. Doesn't matter to me. Normally we don't have warm-ups on Thursday and Friday. Like
Can you go back? Yeah, Josh. Hey. Can I play with smaller moves too, please?
No.
Except I made $1 this time.
Here's your warm-up.
Hold on. Oh, my thing.
Sold this.
I am. 13th all day. What's up on the board? Yeah, I'll take that in a bit. Don't let me forget. All right, so this is not the warm-up. This is the example, and then I'm going to give you the real warm-up. Right?
No.
So, given a maximum of 2 A's and 2 B's.
Oh, yeah.
No, you don't.
Yes, I did.
No, you don't. It's different. Given a maximum of 2 A's and 2 B's, what are the different number of ways we can write this? Now, you might think, well, I can write A, B, and stuff like that. That's fine. That's true. But you can also just write a single A. Or just a single B. We're going to count that as its own thing. You don't have to use all the letters. So, actually, we'll make this the real warm-up. How many ways can you write this? If you're given a max of 2 A's and a max of 2 B's, and it counts if you just use one of them, right? How many can you do? Yeah.
Bang.
Nope, there's way more than that.
Yeah,
There's 6. Like,
So for instance,
quadrillion.
there's like an infinite.
that's a great question. So for instance, you could write AB together, right?
Correct. All right.
Now, even as a question, do we count BA as separate from AB?
Yes.
The question is, what is more interesting, to count it or not to count it? If we count it, right, we're going to get more results, right? But does it really add anything to our knowledge by having it backwards? No. And if we wanted to add it, couldn't you just simply say, okay, everything backwards counts, add that to my chart, right?
Yeah.
Yeah, so I think we should not count stuff that's the same forward and backwards. However, BAB is different than ABB, even though both have 2 B's and 1 A. You see what I'm saying? Go get them.
Wait,
Work
you said-
together.
You said we only have a maximum of 2 each?
Max 2 each.
Yeah.
As long as it is triangle, by bad, not good. Yep. Type that in there. UVSIGEG.
Just like,
Yeah.
Jordan, there's a space in between. Sorry, I'm freaking blind.
I think so.
If you have these and they were totally signed by your parents, I would like them. Okay. Top notch. Cindy. Good choice.
I already gave you one. The day that you gave it to us. Okay, I'm gonna start sharing.
It's like senior share night. I I is a good name. All the possible ways to write out with 2 A's and 2 B's. For instance, 1A, 1B. Or A and B together. Or maybe 2 A's. Yeah, you don't have to use all the letters, but you can use a max of 2 A's and a max of 2 B's. Right? Things that are the same forward and backwards don't count as 2. Sort of, yeah. What's your parents' first name? What's your grade? With an IE. Any others? Alright, Jace, what's your parents' first name? Sally. In my last class, everybody had the same first name as your parents. Mine. Yep. Mine. Aaron. What's the maximum? Find all the combinations. So you could have 1A, you could have 1B, you could have an A and a B. You could probably have 2 A's. You could have 2 B's. You could probably have 2 A's and 1 B, right? But we're not going to order backwards. So for instance, AB is the same thing as BA. So we're not going to count that twice. Yeah.
The syllabus thing required.
Required.
Do you still have mine from last semester?
No. I didn't have any science last semester.
Probably should.
And B. Awesome. I like the use of a different pen.
Oh, you'll have like 5 million.
I don't think it's it. Yo.
Make it a fraction.
Maybe you guys.
I'm so happy right now.
What about this?
I'm so happy. I'm happy because I learned it. David doesn't want to know. You want to know?
Is that like backwards?
You want to know?
Not right now. Yeah. Yeah. But you don't use all the letters.
Sometimes it hurts when I put it in
Alright, that was Triangle by Bad Bad Not Good for their album 3 released in 2014. They're a jazz trio that combines jazz with hip hop, which is like my favorite hybrid genre. Alright, so
You used to talk everything.
I tried to.
Except the country.
No, I do. I just don't listen to a lot. I don't play a lot of the stuff that you guys would be aware of, because like, what's the point? Waste of time. You already know it. Why teach it? Alright, so here's how I did it. To make sure I got every single possible thing. I made a chart, and whenever I move to the left, I'm going to add an A. whenever I move to the right, I'm going to add a b. So if I move to the right from A, I get AB because I add a b. If I move to the left from B, I also get AB because I add a b, or add an A in this case, right? If I move to the left, I get double A. What happens when I move to the right from B?
You get double B.
Double B. Now, can I keep moving to the left? No, I cannot because I'd have triple A and I only have 2 A's available, right? So I can't move to the left anymore, can't move to the right anymore. Bye, Ann.
Wait, can move.
Bye.
Yeah.
Oh, say bye.
Oh, okay. Full pup. All right, so we're going to add a B in this case because I moved to the right. So AAB. I can't move to the right here, so I have to move to the left. And when I do that, I get BBA. Boo. So what happens when I'm here? If I move to the left, what do I add?
Just a.
I add an A, which gets me to the same thing here. And if I move to the right, it adds a B, which gets me here.
What can we just do BA?
Lastly, I add a B if I'm moving to the right, so I get 2 B's. And I add an A if I'm moving to the left, so that's 2 A's. And that's everything. Now there's one last thing I need to do. Only one way to write double A, right?
Yeah.
How many ways are there to write AAB? 2 A's and 1 B.
2.
Well, I could do BAA, but that's the same forward and backwards, so I'm not going to count it. But ABA works, right? And then over here, I get BAB,
Bad.
right? What about 2 A's and 2 B's?
A, B, A, B.
BABA. Give me another one.
B, A, A, B.
Come on. You got one. Bad. Give me another one. CJ. BBA. That's just this guy backwards, so we're not going to count it. Give me another one. ABAB. That's this guy backwards, so we're not going to count it. One more.
Oh, yeah.
I believe in you. Go for it. No, you're doing it. CJ, you're doing it. CJ. Dancing Queen.
Dancing.
Oh, A-B-B-A.
Thank you.
ABBA.
Mamma Mia. Here I go again. No. No, we're not. And there they are. Guaranteed every single way to do it. Put that away. That's your warm up for today. That's it. Nothing crazy. Today, we're going to talk about ratios.
Oh, yeah.
Now, we've sort of talked about this before. For people that are new, I got to kind of catch you guys up because we go a little more in depth in here than I think you guys probably did. Most teachers, when they teach you guys sets of numbers, they kind of just, go through it really quickly and then never go back to it ever again. We deal with it a lot in here. So let's talk about the sets. People that are from here from last year, hopefully you can review this with me. If you don't know it, then we will literally be reviewing it.
It's not real numbers and stuff like that.
Yep, exactly. So, the smallest set of all the numbers has this symbol. That's a 0. Oh yeah, by the way, nerds, my zeros I make like this because then I can make O's like that. I make my T's like this so I can make my plus signs like that. Sometimes I'll make my X's like that so I can make my times signs like that, but generally I have that be my X and I just use a dot for times or parentheses, right? Cool with that?
Very cool. Yeah.
Okay. My 2's look like this, like that, okay? My Z's have a line through them. And the reason I don't do this for a 2 is because there's a symbol in Greek, the Greek alphabet, which you use in calculus a lot, called delta, and it's this guy. And you can see how those can look a lot alike, right? So I don't use those. That's delta. That's 2. That is z. I have more like that. You'll get used to it, I promise. Is there another one I can think of? Anybody else think of another one that I do? I don't use s's because they look like 5s typically. What else? No?
I get it.
Oh, my y's are like this, so they don't look like 4s.
Yeah.
Everybody cool with that? I would encourage you to adopt the same thing. I have one student who makes their y's look literally just like this, and their 4s are just like more boxy. Yeah, it's awful. It's awful. Anyway, that's a 0. It has a line through it. It's an O with a line through it. So, you know what this set's called? N sub 0. What set is that? Set of the natural numbers. The natural numbers are the numbers that you would count your sheep with. Bah, right? Give me an example of natural numbers.
1.
So the set of the natural numbers is 1, 2, 3, and so on, right? That's the natural numbers. It's the smallest set. It's very exclusive. Not very many numbers fit into the natural numbers. Like a third doesn't, right? 0 doesn't even fit in here. It's a very, very exclusive club. What's the next least exclusive, or next most exclusive set?
Whole.
The whole numbers, right? It's a whole other set for just one whole number, right? So the whole number set is n, just like the natural, but it's, oops, sorry, I did this wrong, didn't I? That's n sub 1, starting at 1. N sub 0 is the whole number set. Whole numbers. And it adds one extra number. It's all those numbers plus 0. That's it. What's the next most exclusive set?
Real numbers?
Nope. Real numbers is everything.
Integers.
I already have the whole numbers. Integers. Integers is a z, big thick z, right? Dainty thick. That's all the numbers from before, like 0, 1, 2, 3, plus these extra numbers. -3, -2, -1, 0, 1, 2, 3, and so on and so forth, right? That's the set of integers. So it's all the whole numbers and their flips, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and their negative flips. What's the next most exclusive set? It's not very exclusive, but it is. The rational numbers, and that starts with a Q, right? That's the Q set. And that's every number that's in between these that isn't irrational. So in other words, we can represent it as this, where P and Q are integers. So if you can write a number where the top number and bottom number in the fraction are integers, meaning they're negative or positive whole numbers, then it's considered a rational number. So like 3/4 would work, because 3 and 4 are both going to be integers, right? Another way to do it is if it terminates or repeats. What does it mean to terminate? To end. So a number that terminates, like 0.297, it stops, so it terminates. It's going to be rational. Or repeats. What does it mean to repeat? It's going to have a pattern over and over, like 0.3 repeating, right? That would be a rational number. It's also known as 1/3, which is rational because 1 and 3 are both integers, right? Now, the opposite of rational numbers are irrational numbers, like pi or √2, that have no pattern and they don't stop, and they can't be written like a fraction. Now, you might think, well, pi can be written as a fraction. Pi 1. But it can't be written as a fraction where the top and bottom are both integers. Is pi an integer?
No.
No, it's not, so it doesn't work. Same thing with √2. That's irrational. It never stops. It goes on forever and has no pattern to it, kind of like pi. And it can't be written as a fraction where the top and bottom are integers because √2 is not an integer. So anyway, why did I bring this up? Well, Q is the set of rational numbers.
Ratio.
Ratio is exactly what I'm talking about. The reason it's called rational is because they can be written as a ratio, a number over another number, right? So when we're talking ratios today, that's what we're talking about. We're talking about fractions, basically. Yeah. Yes, you may. It's not here. And fractions are just division for lazy people. Right? Yeah. No one that's in my class last semester may answer this. Anybody that's new, you may. Best of luck. What is 7 divided by 5? New people only. New people only.
1/3. 7/5.
Very good. Baker. 7 divided by 5 is 7/5. What's 9 divided by 13? Anybody? 9/13. That's the answer. Now, could you plug that in your calculator and get an answer? Sure, but it would be a decimal, it'd go on forever, and it'd be gross. You'd have to round eventually. This is correct, and there's no rounding involved. And it doesn't require you to get out a calculator. 7 divided by 5 is 7 divided by 5. Fractions are just division for lazy people. That's all it is. 3 divided by 4 is 3/4. Check it in your calculator. It'll come out to 0.75. But again, why worry about that when you can just say 3 divided by 4 is 3 divided by 4? These are ratios. They're comparing numbers. What we're going to do today is mess around with this. What's another way to write 3/4 as a fraction? Go ahead. 75 over 100. Well done. And how do you know they're equivalent?
Quarters.
25 is a quarter.
He's right.
25s.
3 25s
Great job.
and 4 25s, right?
Yeah.
So we know these are equivalent ratios because there's a number that we're able to multiply the top and the bottom by to make the new one. People that were in my class before don't answer this. Why do we have to multiply to the top and the bottom? Why not just multiply to the top? Why doesn't that work?
Got it, both sides.
Why do you have, well, both sides of the equation, we mean both sides of the equal sign, right?
You gotta have it equal. It's gotta be both sides, like.
When we multiply by 25 to keep it equal, what we really did was multiply by this. 25 in the top and 25 in the bottom. Why is that going to keep it the same? Yeah.
Because you're doing both sides the same number.
Nope, I didn't do it to both sides. I just did it to one side.
Because it's
I only did it to the left side, but we know they're still equal. Remember, algebra says normally you have to do it to both sides to keep it equal, right? Why is it still equal when I've only done it to one side? Why? Think, come on.
People's not off translate things.
You got it? Tickler,
I think.
give it to me. Hold on one second. Pause just in case I didn't get it. Tickler, why is it okay to do it just one side?
Because you're multiplying it from the top and the bottom.
Why is that okay?
It keeps it the same.
Why does it?
Because it's the same number.
Because I've been told it does, right? As long as I do that, it's fine. Why? Think for yourself. Why does this stay the same? Anybody may answer this now. Raise your hand.
I don't know how to explain.
Go ahead, Mitchell.
Because 3/4 is just a simplified equation of 75.
How do you know that?
Because 75 and 100 both
Nope.
divisible.
Why is it okay to multiply by 25 to the top and the bottom, but not to both sides? Why does that do the same thing?
Because it's shall.
Yeah,
If you did both sides, it would get a bigger number on the other side.
maybe. Sure, but why? Why is this okay? Why is it okay as long as I do it to the top and the bottom? Jace,
Make them equivalent.
it does, but why does it? Why is that okay?
Because it's dividing.
What do you mean?
You're dividing it, so like, you would switch it to division. So it's like 3 divided by 4. I gotta shut up.
You're onto something. No, I like how you're thinking. Thank you for thinking. Why is this okay? What's 5/8 times 1?
5/8. Yeah. The one.
What's 9/7 times 1?
9/7.
Why does it give us the same thing on both sides? We only times one side by 1. Shouldn't we have to multiply both sides by 1?
No, because it's the same number.
Go ahead.
It like comes out to a fraction. It's one over.
Because it's the same.
It's onto something. You're on something.
I gotta get there.
But it's-
Why is it okay? I only multiplied one side by 1, but it ended up keeping it equal anyway.
Because it still just stays the same.
Because when you multiply by 1, it doesn't change. Why would I multiply by 25 to the top and the bottom?
Oh, because it's basically
Do I not have to
one.
do it to both sides? It's basically 1. Why is it basically 1? Go. Say.
Two numbers. It's like a number on top of itself.
A number on top of itself. What's 25 divided by 25?
1.
1. I'm multiplying by 1.
Oh, no.
It's just a different way. Math is all about perspective. We are not changing the problem. That's not allowed. You can't be like, oh, that problem's hard. I want to switch it out. I'll do 1 plus 1 instead, right? That's not how math works. We take the problem and we mess with it to make it look different. We aren't changing the problem. You can't be given a Rubik's Cube and say, this is too hard. I'd rather do this one. Thank you. Much easier, right? Yay, I did it. Right? This is the problem. But you are allowed to change it and make it look different. That's okay. So all we're doing here is we're multiplying by 25 to the top and the bottom. So we're really just multiplying by 1. But the reason that we're doing this is because it doesn't change the problem. It just makes it look different. 3/4 is 75 over 100. It's just a different way of looking at it. It's all about perspective. So as long as we multiply the top and the bottom to one side by the same number, it's fine because we're just multiplying by 1. And that doesn't change anything ever, does it? That's why it's fine. All right, before we go any further, I'm going to say this word once, and I'm going to not say it again. I'm just going to get really mad if somebody says it, okay? So you need to know the context clues, what you're not supposed to say. And the reason I'm doing this is because when teachers teach you this method of solving, it works 1% of the time. And for some reason, your idiot brains, which is not your fault, right? You guys have underdeveloped brains. You can't do anything about it, okay? They won't be fully developed until you're at least 23. It's not your fault. You're idiots, but it's not your fault. Okay?
It's a DI win.
We're just no. Nothing as serious as that. I'd be much more serious if it was that. I'm going to say this word, and you're not going to use it at all in here, because if you do, your idiot brains will grasp onto it. It only works 1% of the time. And the 99 other % of the time, you'll use it, and you'll fail, right? So I don't know why your teachers teach you this, because it only works 1% of the time. You are not allowed to use cross multiplication in here. You hear me?
It's that one.
That word will not be used. Because the word that I'm not going to use
It's spelled like this.
and what we do is across. So for instance, if I've got a half times 6/4, we multiply across. 1 times 6 is 6. 2 times 4 is 8. And that checks out because half of 6 over 4 is 6/8. 6 over 4 is just 3 halves. If I've got 3 halves, if I cut that in half, I've got 3/4. That's what 6/8 is. That makes sense. We do not multiply across. That doesn't work. The only time that works is when there's an equal sign in the middle. And you rarely ever see that. Now here's the thing. You're going to be seeing that for the next week or so. I don't want you to get in the bad habits of using this trick when it doesn't work all the time. What we're going to do is we're just going to do algebra. Anybody, how do I solve for x? Divide by 2. Multiplication's going on here. 2 times x, right? How do you undo multiplication? Division. Division is divorce, right? So we divide by 2, and we get x equals 5 halves. Done. Anybody? How do I solve for x?
Multiply by 2.
Multiply by 2. Thank you. That's 10.
Child.
Anybody? How do I solve for x? I multiply by 2. Times by the top, divide by the bottom. When I multiply, I get 10, and then I divide by 9, 10 ninths. And that makes sense. If I have 5 ninths and I double it, now I've got 10 ninths. Right? You with me? If I have 5 ninths before and I double it, now I have 10 of them. Right? 10 ninths. And that's it. No cross multiplication involved. I just got rid of the 2 by times again. That's how you undo division, right? Thank you. Do not do cross multiplication. It will screw you up later. It'll help you for this, but it'll screw you up in everything else, okay? So let's talk ratios.
Yes.
What over 7 is the same thing as 7 over 49? Is really what this is asking, right? Great. Let's do algebra. How do we solve for x?
Multiply by
I think I know this one.
Right? I had 7 49s, now I've got 7 times that, right? So now I have 49 49s, which is equal to what?
1.
Is it true that 1/7 is equal to 7 over 49?
That is true.
Yes, that's true. They're equivalent. They're the same ratio, right? As you were talking about earlier with 3/4 and 75 over 100. They're the same crap. What we're trying to find out is what number, and it's going to be the same number for the top and the bottom, and we know why now, right? Is going to multiply this guy to make him 7 and this guy to make him 49. Well, 7 times 7 gets us 49. And we have to do it to the top and the bottom, so we're really just multiplying by 1. Doesn't change the problem, right? And that'll tell us something times 7 gets us 7. Well, 1 times 7 gets us 7. That's why they're equivalent ratios. So we're looking for a number that relates them. We call this number k. So 2 ratios are equivalent, like 3/4 and 75 over 100. 2 ratios are equivalent if there's a number k that multiplies the top to the top and the bottom to the bottom. So if there's a number that's the same for both, then they're equivalent. What's the number here that takes 3 to 75 and 4 to 100?
25.
25. No one think funnier than 24. SpongeBob, anyone?
Yeah.
My kids know. My new kids don't. All right, so is 1/2 the same thing as 5/9?
No.
How do you know?
Because there's not a number that you can multiply by.
Parker's right. No one was listening. I'm going to ask again. Parker, don't answer. How do I know 1/2 isn't the same thing as 5/9?
Well, I'm always saying.
Because it's not.
Someone from the right side of the room. My right. Your left.
These books aren't real.
Baker. How do I know 1/2 isn't the same thing as 5/9?
Because they don't equal.
How do you know? Lexi.
Because it's not divisible by each other.
You're very close. You're not wrong. That's not the way I want to be.
Because 2 doesn't go to 9.
And very rarely do I nitpick about that. But I will say it. Okay.
2 doesn't go into 9.
All right. Preston.
Yes. Two doesn't go in 9.
You're right. It's the same thing Lexi's saying, but I want to hear something different. Yeah.
Right.
Like divide by that.
Oh, you're so close. All right.
Multiply. I don't know. Something like that can be 5 to 1.
Gentlemen, I need you to focus, please. Ratios are only equivalent if there's a number you can multiply them both the top and the bottom by to make them match. Is there a number k that makes them match? No, because what times 1 gets me 5? So that's saying k has to be 5. But does k equal 5 work for the bottom? It does not. So there's not a single number that makes the top and bottom match when you multiply. So it doesn't work. You're basically right. Okay? We're looking for a number k. That's going to be the same for the top and the bottom, that when we multiply the top, we get the other top. 5 works for the top, but doesn't work for the bottom, so they're not equivalent. They're not the same thing. Here's what I want you to do. I'm going to give you some homework. You're only going to do the front page. What? Oh. We're going to do the first one together.
Do you have homework in this class?
You do now. Remember, homework is a rough draft due tomorrow. Don't pass back in here. We don't do that.
Oh, we don't pass back.
No, we do not. We do not pass back. Give him the other one. I do. You have to staple it yourself. I'm sorry. The copy machine that's down here doesn't have an automatic stapler, and I'm too lazy to go upstairs to print it. Here's my stapler. It's super nice. The other one I have on my table is a piece of junk.
Yeah, you yell at us.
Yeah, where's my red one? Oh, it's in the back. Why are you running? Another way. Only do the first page.
So I have to solve for x.
Let's do the first one, yeah.
You don't pass back. Only the first page.
What is a proportion? A proportion is a ratio that's being compared to another ratio. So So a ratio, equal sign ratio, that's a proportion. Two ratios being compared. Yes.
I need paper.
All right, come here.
We only do the front page, right?
Yep. How do we solve for x for number 1?
Multiply by 3.
We multiply by 3. So x is going to be, if I have 9/5 and I triple it, how many fifths do I have now?
27 fifths.
27 fifths.
700 fifths.
So x is 27 fifths. Now don't be alarmed. That means if we were to plug this in, we'd have 27 fifths over 3 equals 9 fifths. And that makes sense. 27 fifths divided by 3 would be 9 fifths. Think of fifths as a unit, like 27 chickens. 27 chickens divided by 3 would be 9 chickens. That's all they are. I don't know why your teachers confused you so much about fractions. 9 fifths is just like saying 9 chickens. I have 27 chickens, I divide by 3, I've got 9 chickens. That's very nice. Do you eat them or do you just have the eggs? Okay, I'm vegetarian. I don't eat them. I was just asking because I will buy eggs off of you.
Vegan eating side by
You
side.
said that post about soup or something.
What?
Showing everything.
What'd you say?
I will buy eggs off of you if you don't kill them after
I thought you were gonna bring in that 100
Okay.
spice soup stuff.
A freaking cook some cabbage.
Look at number 2. How do you solve a problem like Maria?
Alright, so what you do?
You know.
I know this. Do you?
Parker.
I don't know.
You multiply.
Multiply by x.
Multiply by x. If there was a 2 under there, to get rid of the 2, you'd move it over, right? Let's move over the x. We get 1 equals 2x. And yeah, that didn't get x any closer to being on its own, but I think you can see what we got to do now, right?
Oh, I know.
What do we do?
Yeah, divide.
Divide by 2. So a half is going to equal x, which means 1 over a half equals 2. If that makes sense. 1 divided by a half is 2. Remember, division is the same thing as multiplication when we reciprocate. So 1 divided by a half is the same thing as saying 1 times what? What's the reciprocal of a half?
2 over 1.
2. And doesn't that equal 2? Check. There we go. 3 and 4 are on your own. That's all you have for homework. We're going to do these other ones tomorrow.
Just 3.
Yep. I want you to buckle up for tomorrow. Tomorrow's going to be weird. It's going to be confusing. I need you to stick with me. Parker and Shambaugh, I'm about ready to split you guys. I know you guys are having a good time. Tomorrow I need your full focus. Shambaugh, Parker. Tomorrow I need you to have full focus. So I want to move people now if you're not going to be able to handle it. That way you're ready to go for tomorrow. Because tomorrow I guarantee I will lose you. I will. Okay? All right, please. You what? No. It's all new tomorrow.
I think, can I did this right. I don't know, I just,
You only have to say it once. Like,
Yeah, I don't know.
So this one makes sense, right? Because 3 is going to take it to that. So here's the problem. Actually, no, it's fine. It would be 3, right? Because 3 times 3 is 9.
He gets angry.
I want you to practice solving it because right now the problems are easy enough where you can eyeball it. But imagine if it wasn't, right? Then you'd be screwed. So practice showing your work now when it's easy. That way when it gets harder, you can actually solve it, right? Like right now it's right. So here's what I'm saying. Okay? So we want to
Don't open it. You know the thing must open when you open it.
Right.
I didn't do a right
So I
way.
get 9 halves times 2. What's that? I'm multiplying by 2. What do I get? Over 2, right? So I have 9 halves now. So it's 18 halves, which is
Don't do that.
oh,
Hey,
wait,
let's
I
do it.
just.
Let him learn. Let's
He's already learned.
Now.
Do
Do it again.
Don't do that.
Give me your glasses.
No.
My advice is get the x out of the bottom. 1 second.
I've lost myself.
Oh, I know it, bro. I know it.
Good job.
Don't look at my answer, bro. I know it. I was all like,
Nope, X is 3, you're good. I was just showing that it did work earlier in my work. That's all. That's That's what that 2 times 1 is. Yeah.
I lost myself already.
Alright. So, how do we get x on its own? Right now it's being divided by 2 times 3. What do you want to get rid of first? Okay, so how do we get rid of times 3? Okay, so we divide by 3. The 3's gone. That's why we did it. We multiply this by 3. We've got 9 halves. So we triple this. How many halves am I going to have after? 27 halves. Now how do I get rid of the divided by 2? Of x, right? 27 halves doubled to be 54 halves. This is the easy way of doing it, right? When I'm multiplying by 2 and dividing by 2. Right? So 27. Right, when you take a number divided by 2 and then double it, you just get the number you started with. Oh, wait, you made a mistake. I trusted you. Sorry, I forgot. I do this all the time. New people. I will old people, you know this as well. If you guys tell me the wrong thing to do, I'll still do it and not mention anything, right? And you guys will figure it out like 10 seconds later, like, oh God, we screwed up, right? I'll do that on purpose. So watch out for that. All right. You said divide by 3. What's 9 halves divided by 2? Okay, so we're getting rid of 3 by divide. 9 halves divided by 3. Does that make sense? So if I have 9 chickens and I divide by 3, I have 3 chickens, right? So all the 9 halves, I have half the thing, right? Now I have 3. Now I have 4. And this checks out. Now I have 3 times all of these. Work with your buddy Parker on this. He's all right.
I don't know.
Alright, so we need to get x on its own. We get rid of divided by 2. And we get rid of times by 2.
Mr. Matt.
What's up?
Well,
Yeah, 4 is not
well,
easy.
only the front page, right?
Yep, only the front
Oh,
page.
on
No, we'll do that. Who's got 4?
me.
I don't.
Lexi, tell me how we do 4. She might not be right, and that's okay.
2x equals 9, and divide that by 2, and x equals 9 over 2. Whoa.
That won't work.
Wait, I will.
Nope, because 3 and 2 aren't equal. It worked earlier because 2 and 2 were the same.
That's kind
You
of.
see what I'm saying? If we figure out what makes 9, then that becomes a 9 over 2, which is what we want. Alright, common mistake. I was hoping Lexi would do this. Thank you. So check it out. Lexi earlier was like, look, if I know 3 times 3 is 9, that means if x is 3, I get 9 up here. 9 halves is 9 halves. I win, right? Here, the top and bottoms aren't the same. So if she gets 9 here by timesing by 4.5, 2 times 4.5 gets me 9, but it's going to be 3 over 9 and 2 over 9, not the same. So what do I do, Mitch?
Divide the 2x on both sides.
Undo the divides by 2x?
Yeah.
How do I do that?
Multiply by 2x.
Okay, so I get 3 there. I times by 2x. Now I have 4x over 9. Everybody with me there? You seen how I did that?
Yeah.
I times the 2x over. We times by the top but divide by the bottom. So we get 4x divided by 9. Now our goal is to get x on its own. So I've got 4 times x and divides by 9. How do I get rid of the divides by 9?
Multiply.
Go ahead.
Times 9 both sides.
Times 9, I get 27. Lexi, how do I get rid of times 4? Exactly, so I get 27 divided by 4. Do not plug that in a calculator, I swear to God. 27 divided by 4 is 27 over 4. That's it.
Yeah.
Beautiful work, guys. Come back tomorrow. Great work.
We just did the whole
Come, Preston.
Yeah.
Hey, Logan. Great game, Sam. Great game, guys.
Taught me well.
Great game.
I just did all that. I'm stupid because it's so
So you just gotta review.
I think Jordan, can you like give somebody else scoliosis?
Like, can you catch it?
Yeah. Like, okay, I have my back popped out and I have a.
Why is that? You shouldn't. That's not normal.
I know. I think I sat my back a lot.
Yeah, don't do that.
I find that.
Why does he have gloves on? No, why didn't you have gloves?
Oh, we have blinds today. This Matt kind of says for us in class.
Did you fart? Yeah. I saw that. Why?
The New Year blimp. Big year blimp.
Can you take it back and like? It's very nice of you, and it's not. It's definitely. Thank you, but it's also not. Okay. Well, you know. Thank you very much ahead of time.
It's because your car doesn't have keys.
It doesn't have to.
Over right here.
Are you gonna hang out in the room or are you? Okay. Have fun.
Got a problem with my gloves?
Go away, all of you.
I'll be back here for
Make sure you understand 1 through 4.
Okay.
Not just complete them, but understand them.
Wow.
Goodbye, Tickler.
I'm gonna go sit through another 45 minutes of this read.
That's right.
It's blind, so.
Except it's not 45 minutes, right? No, it's. Oh, it is, kind of. Except no, it's not.
All they do is fight. Like, I was at a basketball game recording once, a Brittany game. All they did was argue. So. Then they made up. Then they started arguing again. At least that was just fast enough to kill it so bad. Hey, one of your thingy about is broken.
Yep, I know.
I had Dylan send a bunch of girl snaps. I said he added off his random like things, and he sent me Marvel, and he didn't realize this person's like emoji had a beard. And he thought it was a girl. It's a guy with one hair like a beard. And me and this guy thought it was Snapchat. He's like, the worst. He's like, that's the move. He's chill. I forgot what he's from. He's passed out. Another one added that. And this is from a couple of days ago too, so there was at least 50. You know who Gabriel Rodriguez is?
Hey.
You know, I'm kind of nervous.
What's that?
You know, the doctor appointment to see like, there's like certain things on my leg, and I think it might be skin cancer. And that's scary.